And
Okay.
I just briefly looked at what you wanted to cover, but I'll just, for the point of this, I'll just show you. Let's say we're looking, we do a problem like this. We'll talk about how to do this in a moment, but I'm going to share my screen the whole time. I will work on problems.
Okay.
I would recommend pencil and paper to take notes, but I do send you this as a PDF at the end of the lesson. And
Okay.
I'm also recording it. So you'll get a link to the YouTube channel and you can go there and search for your lesson if you
Okay.
want. So before we get started though, how is your summer going? Have you done anything fun?
It's gone good. The first few days of summer, I went to Texas with my mom's friend, and I've been doing basketball since I got back. So that's pretty much it.
Oh, fantastic.
Yes.
I didn't know you played basketball. Are you watching the NBA finals or at WNBA?
I'm not. No,
WNBA maybe coming up? Or I
not
don't know,
really.
not really.
I mean,
Okay.
maybe, but
All right, now on to the less fun stuff, math. So from what I understand, there were some, I'll just say issues at the end of the year. I'm not really, it doesn't really matter to me. I'm not going to get into all that, but just for your benefit, I know that you want to do some of these assignments to get caught up. I'm not really sure. Could you kind of give me what your goals are, what you're trying to accomplish with the lessons?
so I have the lessons that I need to work on from like the things that I didn't understand,
Yes.
and so just I would just go through those lessons, and then I know the assignments that I had to do in school, and I would probably just redo those assignments.
Okay. Great. So what I tell students, what I tell, you're the customer here. I tell you, um, whatever you want to work on, and that could mean review. It could be the assignments. It could be really anything. So
Okay.
if have you already done the assignments, I guess is the
I
question.
have, yes.
You have. Okay. So this is not about like doing the assignments. This is just about maybe getting some more information about the maybe
Yes.
getting okay. Fantastic. All right. So for summer, I keep the lessons kind of short. Normal
Okay.
lessons about 50 minutes. We'll probably go 30, 35 here for the first one just to see how it's going.
Okay.
And I do want you to do some problems. That's why I asked you to have some pencil and paper out, but
Okay.
we'll get to that. So from what you sent by email, it looks like you're just working on properties of exponents. Is that right?
Yes.
Okay. Now, do you generally get assigned like odds or evens when you do these?
We usually get assigned the odds.
The odds. Okay.
Yeah, that's pretty much it every time.
All right. Okay. Well, let me just start by grabbing a problem here, number four. If
Okay.
you're able to see my screen, I hope.
Yes.
Great. So number four here in this it says 8 to the 5th times 8 squared, and there's a property that goes along with this type of problem. It in words, it's probably more meaningful when the bases are the same and you're multiplying, you add the exponents. So
Okay.
what sometimes you see in textbooks is something like this, where they give you something like this on the left, that's where the bases are the same, and then they show you on the right this, and
Okay.
then sometimes they give you the words that go along with it. They'll say it's the product property or something. That's not really important. What's important is that you can actually recognize, oh yeah, the bases are the same, so I add the exponents.
Okay.
And there's no expectation that you know this number. There are some that you might want to know, like you might want to know 6 cubed, for example. That might be a good one to use, like if you're planning on taking the SAT or
Okay.
the ACT.
Okay.
There's some ones that are worth knowing there.
Okay.
All right, so let's go to a problem like number 6 here, and you can tell me if, hey, like I already understand this. This is too slow. We're just adding the exponents here, so it's 9 to the 6th. If the exponent isn't written, it's a 1.
Right.
Probably saw that. Okay, and then what I do like here is sometimes the textbooks don't do a good job of showing kind of all the possible variations on the problem here. The
Right.
the thing, the exponent here is 1, but the base could be positive, it could be negative, but we know that it's put in parentheses, so this would be -6 to the 7th, and so on. Any
Okay.
questions on that so far?
No.
Great. So let's move to something with some variables in it. And there's obviously a lot more of these properties to cover.
Yeah.
Let's go to look at something like 22. So this is a to the 4th times a cubed times a to the 10th. So while the property I gave you only had 2 things, you could obviously keep going with this indefinitely. You could just use another letter like r, and this is x to the n plus m plus r. So this one would be 4 plus 3 plus 10, which is 17. Now, I'm pretty sure you understand all this just based on the verbal cues you're giving me. What though? How would you handle something like this right here? What would
So would it be?
you're still adding the
Is that a
exponents?
negative?
It is,
By the
yeah.
x, or is it okay?
I'm sorry. Yeah, that's a multiplication. Sorry, that could sloppy
Okay.
there. Yeah. So you still add the
So it'd be
exponents.
right.
So that would be x to the 1. Now let's say it was 5 to the a times 5 squared times 5 to the b.
Okay.
What would this be?
Would it be 5 to AB?
So you're always adding a plus 2 plus b.
Okay. So okay.
And so sometimes they simplify, sometimes they don't.
Okay. So
All
you would
right.
just leave it like
Yeah,
that?
like, and this is uncomfortable, right? Because you feel like, hey, I got to do something with it. It's like, well, yeah, but there's nothing to do. You can't combine them.
Okay.
So let me just do a couple problems here. Let me clear the screen here. If you need me to go back, I can scroll up, but let me have you do a couple problems here that I think would be worth doing. And then we'll go back and look at some other, let's watch, I'll just make them up here. So let's say it's x to the 5th times x to the 7th. Number 2 will be y to the 8th, y to the a, and then number 3 will be m to the 5th times m to the -3 times m, like that. So just take a few minutes there and see if you can work those out on your own, please. And let me know if you have any questions.
Okay. The first one would be x to the 12th.
It is x to the 12th, agreed.
And the second one would be y 8 plus 9.
This is an A.
Or a 8 plus a.
Yeah,
Sorry.
so my handwriting isn't great. So always ask if there's something that's unclear. And do you have the last one?
M to the 3rd.
Yep. So it's m plus, I'm sorry, it's 5 plus -3 plus 1. So it's not written. Yeah. So I think you said 3rd there. Okay, perfect. Okay, so now new property. So the new property here would be for a problem like this. You actually already know. So let's say you have 4 times 3 to the power of 2. What is 4 times 3?
12.
12 squared is 144. So we already know the answer. But sometimes it's good to look at the property when you already know the target. Okay. So the property says, well, it's 4 squared times 3 squared. So is 16 times 9, 4 squared is 16, 3 squared is 9. Is that 144?
Yes.
It is. So the property says if you have a times b, I'm just going to throw in a third letter, c to the n, you can actually have as many as you want. It is a to the n times b to the n times c to the n. So basically the exponent is applied to everything inside there. Now, there's really a 1 here, a 1 here, and a 1 here. So you're really actually multiplying them.
Okay.
So this is the property, and there's a couple of cases on it we're gonna look at now. But in words, you apply the exponent to each exponent by multiplying. So the most basic case, or case number 1, is I give you a number. I'm sorry, I give you a base to an exponent
Okay.
to yet another exponent. So when you have an exponent to an exponent, just like you see here, you multiply. This 3 multiplies this 4. So it's 7 to the 4 times 3, or 7 to the 12 power.
Okay.
So let's do another example here. Let's say it's 5 cubed to the power of 2. Do you see that this would be 5 to the 3 times 2 power, or 5 to the power of 6? Do you see that?
Yes.
Okay.
So for that, you would just keep the base and multiply the exponents, basically.
Right. So because you only have one base, whereas in the previous examples we were doing, you had 2 bases because you were multiplying. Here you
Right.
just have one base. You have an exponent to an exponent, so you multiply.
Okay.
And that's the word I like, exponent to an exponent. I'm not like I love the math, but the words mean more to me because we're
Right.
native English speakers. So let's
Okay.
use them and try to make some sense of that. So now moving to what I just mentioned, which is like, well, let's say you have more than one thing inside here. Like, let's say it's 5 times x to the power of 2. Well, this 2 applies to each exponent. So it's 5 to the 1 times 2 times x. That times comes from here, x to the 1 times 2. So that's 5 squared times x squared. And that's really the property. The property is that the exponent applies to each exponent inside.
Okay.
And for preference, to make this kind of like to pretty it up, is you would actually reduce the exponents that you know.
Okay. Okay, so I see what you did with the 5 squared.
Yeah, so let's do another here. Let's go 3 times y squared to the power of 4. So if the exponent isn't written, you should write it at least until you get more comfortable. So this is 3 to the 1 times 4 power times y to the 2 times 4 power.
Okay.
Is that clear?
Yes.
Great. So this becomes 3 to the power of 4, y to the power of 8.
And then you would reduce the 3 to the power of 4, right?
Yes. So what I'd like to do here, and you can go ahead and try simplifying that on your own. I'm going to send you a link to a reference sheet that is on my website. I've got some. I don't have all the ones that I would ever want, but this is the one I'm going to send you is a link to the exponents that I feel like are worth remembering.
Okay.
And it's for speed. Like it's not because I think you should know them. It's for if you want to do well on standardized tests. Oops, let's keep sharing that. So in the chat here, I'm going to just put a link in the chat. Then I'll snip it in as well. But for standardized tests, you have to be fast on some of this stuff. And this is one of those things that if you can get really good at them, then you just get more time. And time's like always working against you on those things. So let me get to where, there it is. It's not an infinite list either. I mean, it's like some reasonable ones that could help here. So you snip that in. So you got a link to it. I'll put a link in the email also. But the way you use it is if your base is 4 and I ask you for 4 to the third is 64. You'll notice they're not all filled in because some of them get too big. It's like, you don't
Right.
need to know, you don't need to know 3 to the 10th, but you ought to know 3 to the 6th, roughly.
Okay.
Okay, so let's move back to the stuff you want to work on today, which is continuing with this property here. So let's try another one here. Let's go 4x squared y cubed to the power of 2. Will you try simplifying this one on your own, please?
Okay. Okay. Would it be 4x to the 4th, y to the 6th?
So the one you did not evaluate is that one. You have to
Oh, right.
evaluate the one that's not written. And that's me being a little deceptive, but it's like in math, it's like understood to be there. So it would be 4 squared, which I think as 16. And then,
Yes.
yeah, so it's 16x to the 4th, y to the 6th. Let me try one more here if you don't mind.
Okay.
Let's go 2x y to the 5th to the power of 3. Could you try that for me, please?
Yes. Okay, would it be 8x cubed y 15?
Perfect. Excellent. Okay, so let me go back and look at the pages you sent me because I think we can now move on to, and we need to spend just a tiny bit more time. And there's a couple other cases that I'd like to show you. So let me first try this. This is negative 3 squared. Okay. So let me actually just frame the screen with just this out front. By the way, can you hear a dog barking in the background?
Faintly, but I mean,
Faintly? Okay.
not too
I didn't.
distant.
Sometimes I don't know how well people can hear what's going on. It's not me. It's someone else doing that. Okay, so this is negative 3 squared, but here's the way you as a math student want to look at this. You want to either see that it's negative 3 squared because of order of operations,
Right.
or if you prefer negative 1 times 3 squared, that's okay too. But what you have to like be able to do here, which is I think one of the hardest things for math students to do, is like understand that, like, even though we write it this way, this is what's meant. One of these where this negative is like off to the side. This is the problem you're doing. You have to do 3 squared and then negate it.
Okay.
Okay, so this is, it's obviously it's 3 squared is 9. You negate it, and it's negative 9. Now, not to be confusing, but just to show you, why this is important. Negative 3 squared in parentheses is truly negative 3 times negative 3, which is 9. But now let's look at it in the context of what we've been doing here. See how I can separate it like this?
Yes.
And we previously said this is raised to the power of 2, and then this is raised to the power of 2. So it's actually, and I know there's a lot of parentheses here, but it's this is what's being raised to the 2 is the negative 1, which is why it's 1 times 9, which is 9, the same as this.
Okay.
So I don't expect you to fully understand that, but what I do want you to be very careful of in the next few examples that we do is try to really focus in on like whether the negative is part of this thing we're doing. So like if I ask you negative 3x to the power of 4, okay, what this means is this whole thing in parentheses negative 3 is raised to the power of 1. This x is to the power of 1. So this 4 goes to both of them. So it's parentheses -3 to the 1 times 4, x to the 1 times 4.
Okay.
And this becomes -3 to the power of 4 times x to the 4. And -3 to the power of 4, it's either 81 or -81.
Right.
Do
Okay.
you have clarity on which one it is, and could you tell me why? It's okay if you don't know. I'll just so let's come back to it.
I think it would be positive because
okay, don't guess, because the guessing kind of leads you down this road of like you guessed right one time, so you think, oh, I'm a good guesser. Let's not do that.
okay.
So let's do this. Let's do -2 to the power of 1 is -2. -2 to the power of 2, notice it's on parentheses, is 4. -2 to the power of 3 is -8. -2 to the power of 4 is +16. -2 to the power of 5 is -32. So what you should notice is there's a pattern here. These numbers are negative, and they associated with these exponents.
The odd numbers.
Yes, exactly. So the rule is a negative number raised to an odd power gives you a negative exponent.
Okay.
Raised to an even power gives you a positive. Now, I don't like rules. I'm not big on like, oh, let's memorize a bunch of rules. I would remember one of them and then know that the other is opposite. Like, know that even powers give you positives, so odds by, being the opposite, do the opposite.
Right.
Okay. But again, be very careful here, because the parentheses holds the negative number, like that, and that's kind of what I was trying to show you earlier. It's like, are these the same? That's rhetorical. Don't answer that. What I want you to be able to do is realize, okay, this on the right means that it's -2 times -2 times -2. Okay, or using the rule we just talked about. But on the left here, that negative is really out in front.
Okay.
It just comes along until you get your answer.
Okay.
And sometimes you get the same answer, but just it doesn't always work out like that. Math is full of exceptions if you haven't figured that out by now. Yeah. All right, now let's get back to some problems that you were doing. So here, I want you to try this one on your own, please.
Okay.
And it's okay if you don't get it right or you have questions, but go ahead and give that a try, please, on your own.
It's clean. I mean, this thing's got 94,000 miles. When I priced it on Kelly Blue Book and on Auto Trader and all that, I just priced it at 195,000 miles. But I don't have that many miles on it. Cars.com said, the value should be, I want to say it was $5,073.
Okay. Would it be 25x squared?
Perfect. Yep.
Okay.
All right, so let me give you another one here. See if we can find this.
It's been taken care of. It's clean. There's a dent right above the bumper, a little. And
all right, could you try this one for me, please?
Yes.
It's just one of those little corners. But I don't know of anything, man. Go front rear seats look good. I honestly don't know of anything that the airbag light will come on the dash off and on, and I did look at that twice, and it's there's a underneath the passenger seat is where the airbag connects, like the sensor, like if somebody's sitting in it or not sitting in it, and that they've taken it apart and cleaned it. I think that sensor just needs to be replaced. But that's as far as
Okay.
like checking.
I think it's -512 m to the 12th.
Perfect.
Okay.
Okay, fantastic. So now let's take 30 seconds here. have you done a virtual lesson like this before? Have you done
No, I
online?
haven't.
You have not. Okay. Let's just take like a 30, 60 second, just a screen break. And I'll just check back with you in about sorry, 1:28. I'll check back with you.
Okay.
Just take a short break.
Oh, that's fine. Absolutely. You know what? I mean, I'll be at, I'm there at church every day. Just about Friday is the day that I try to pick up, but I live near Prince and Flowing Wells. And so that's where I live, and that, it's with me. But yeah, that's no problem at all. And if I've got it at church and you need to take it to go run, then yeah, no worries. I'm not going anywhere. I've got a youth camp the last week of the month, so I'm in town this week and next week, and then we leave the following Sunday for youth camp up in Prescott. And I'm not taking it with me, but I mean, I'm just saying I won't be here. So, but yeah, anytime, no problem. You got it? No problem, sir. What was your first name? Thomas. All right, Thomas. Thank you, sir. Easy, brother. They're a home health care. He says him and his wife go to Victory. Victory's kind of gotten too big for them. And he goes, I didn't tell him I want you. He goes, I was following behind you on Orange Grove.
All right, Tabitha, how you doing?
I'm good.
Great. How's this working for you? What do you think of the format here?
I like it. I think it's working actually. It's
Good.
helping a lot.
Good. The screen is a little bit much, if you haven't stared at a computer screen. I know we're on our phones a lot, but like just looking at a screen, it's actually very immersive. You got to be careful that you don't, strain your eyes because you're staring so intently at a screen. But
Right.
so now let's just talk about, and you've probably heard this word, synthesis, in the math classroom. Hopefully you've heard it, or maybe in other classes. So for me, like this is the combining of a couple of properties. So this is like me giving you a problem like this: m squared to the power of 6 times 2m to the power of 3. Okay. So we're gonna combine some of the properties we've talked about today, just to kind of see if you got as full of an understanding as you need here.
Okay.
So just break this apart here. What would you do with the first piece of this?
I would go 2 times 6.
You have an exponent and exponent. Yes, you multiply m to the power of 12 times, because there's an implied multiplication here, 2m to the power of 3. Now, if you're not sure how to answer this, I'm going to give you a question over here off to the side. If you take 2 times 3 times 4, which is 24, but you instead do 2 times 4 times 3, do you get the same answer?
No.
So 2 times 4 is 8. 8 times 3 is...
Oh yeah, you do. You do.
Yeah, so this is one of those properties that isn't really important to know the name of, but it is important to recognize that the order doesn't matter sometimes, but sometimes order does. So the reason I brought that up is you can actually combine these two. The bases are the same, so what do you do to the exponents?
You add them.
You add them. So it's m to the 15th. And then by convention, the 2 would go first here.
Okay. Yeah, that makes sense.
Let's do another example and see if you can make some progress. Let's go b cubed to the power of 5 times 4b squared. Okay. So you can actually tackle either part of the problem first. Like you can do the left piece or the right piece. It actually doesn't matter. In the previous problem, there was actually nothing to do on the right, but on so your choice here. Do you want to work on the left or the right?
I'll go left.
Okay. You have an exponent to an exponent. What does the property tell you to do?
To multiply the exponents.
Okay. So b to the power
of 15.
Okay.
And then the right, I would... I don't know how to explain what I'm doing.
That's okay. That's a hard part to do. If you give me the right answer, that's okay. You can work it out. I'll help with the words if needed, but math class is about what you write down, not what you say most of the time.
So would it be 4 to the power of 2, b to the power of 2?
Yep.
And then that would be 16.
16. Okay, now how about these right here? What do those combine to? The bases are the same.
It would be b to the 17th.
Very good. What grade are you in?
10th grade.
10th grade. Okay. So I had a 8th grade algebra 2. Well, I don't even remember. It was probably algebra 2. But he scared everyone in the class when he said, "You're gonna have to come up to the front of the class, and we're gonna give you a 3x5 card with I think it was foiling or something on it." And he's like, "You're gonna have to do the problem out, orally, out loud." And it stayed with me, all these years, because it's kind of an odd thing to ask a student to do, because you just write stuff down. But
yeah,
so just I don't know what kind of a learner you are. I got a feel for that as we keep working together. But if you need to talk out a problem, I think that's great. If you like to internalize it, that's fine. It does ultimately matter, what goes in the box, when you're
right.
When you're done here. Okay, so let's try another problem here. Let's go, we'll do a couple more. Let's go c squared to the 4th times c to the -3 squared. So give this a try. If you follow the rules we've been doing, you will definitely get the right answer.
Would it be 6 or c to the 12th power?
Let's work at this one piece at a time. So you just think it's c to the 12th. I'll write that over here. 2 to the 4th, you multiply them.
Right.
Okay.
Oh,
because it's exponent.
I think I added them. That's why, because I got c to the 6th.
This is c to the -6 though, because you're multiplying. And I threw in a little wrinkle there just to see if because you got to follow the words, like 2 times 4, -3 times 2. So you're now multiplying them, but since the bases are the same, you do add the exponents. C squared.
Okay.
Let's try one more. All right, let's go x to the 9th squared, 2x to the 4th. So give that a try, please.
Okay. Okay. I wasn't sure if I did the right side correct.
Okay.
Got
tell me what the left side is.
X to the 18th power.
Okay, good, because you have an exponent and exponent, so you multiply.
Right.
Over here on the right, if you didn't do this, it's good to write the ones, and then this 4 applies to both of them.
Okay.
Does that change anything for you?
It doesn't.
Okay.
But I would multiply the 1 and the 4 for each, right?
Yes, yes.
Okay, so then I did it right. Okay.
Okay, and then 2 to the 4th is 16. 18 and 4 add up to
22.
22. All right.
Okay.
So this is we're kind of coming to the end here. This is where I would recommend you going to page. Well, I don't. The 8.1 exercises. What I would recommend doing is looking at some of those and seeing is there any there that you're like, oh, I don't know how to do that, or they are unclear.
Okay.
There's a few here I did not cover because they're what I would consider sort of exceptions, but like 25, for example, if you happen to have that out.
Okay. I do.
Yeah, and we can talk about how to do that, but it's not like critical to understand this concept. Like there's exceptions and then there's extreme exceptions, and that's what like 25 and 26 are. Now maybe your instructor gives you those, so we have to cover those in more detail. But that's what I'd recommend is, and you don't need to do it right now, like maybe wait later in the day or in the morning, but I would recommend trying to see like what stuck with you from today's lesson.
Okay.
So yeah, if you got time, I would take care of that. I'm not, I'm not the parent, so I'm not going to say like you must do these problems. I'm going to just say, hey, it's up to you. I will give your dad some feedback. At some point, I'll give him a call later today and let him know. And the main thing I'll let him know is that you're a great student to work with. I feel like you followed along very, very well with the stuff that we did. I did notice that when we got to like synthesis problems where you had to combine more than one property that you struggled, but that's what most students struggle with. So that's to be expected, nothing out of the ordinary. And if you guys like this, we can, keep doing this at some regular interval the summer. But please let your dad know what you liked, your mom, what you liked, didn't like, or if there's anything else I can do to help make this better for you.
Okay. Well, thank you.
You're
I
welcome.
appreciate it.
Absolutely. So I'll send you an email here shortly with the notes and the screen recording, and I'll see you next time.
Okay, perfect.
Have a great day.
Thank you.
Bye now.